So
Sure, thank you. Yeah, I think when I met you, I remember you saying that you were making these interactives in Flash, I think, and you're saying you wish you'd known about Geogebra earlier because it was costing sort of $500 to make these things. Geogebra, we've made Geogebra to be a system for students to explore math, but kind of by mistake because of that and because of the flexibility, which I'll explain a bit in a minute. But because of the flexibility of it, it's a really powerful authoring environment for making manipulatives. So I mean, that's our secret business model is we give it away to schools and teachers, and then publishers, if they use it, then obviously they need to pay. We can really focus on our core thing, which is having it free for students and teachers. And that's what makes us happy. And then,
how did you first encounter GeoGebra? And I wonder if you could tell briefly of your background.
So I was a full-time math teacher, and I'm still teaching 2 mornings a week. So yeah, I was using. I think a friend came home from some teacher training. He went down to London and came back and said, I was sort of interested in computers and interested in dynamic geometry, and I'd made my own rather primitive version. And he came back and said, you should look at this. So I looked at this, and I wasn't first taken with it, but then came back to it. And then the first thing, we had Moodle in school at that point. So the first thing I did with it was making some circle theorem interactives. And then I wanted to add arrows to show that 2 lines are parallel. So I delved into the code a little bit and changed that, and it snowballed from there. I think it soon became every evening and weekend since 2007. Marcus, the founder, started it as his master's project. So actually the reason it came about was he was doing joint honours maths and computer science, and he had to do a project for maths and a project for computer science. So being a sort of efficient sort of person, he just wanted to do one project. So.
And this is one thing I've noticed, and maybe you can give me your take on it, but there's is the community aspect of GeoGebra.
Exactly. So when you say GeoGebra, I mean you can refer to the software, but actually the community now is actually as important, really. And it's interesting how different countries use different aspects. For example, France, they used to use a different software, and they all used a particular one. It's very focused on geometry. So then they were used to using that. So now they all use GeoGebra, and they've kind of come into it through a different software. Whereas the Spanish-speaking world seems to have started off really with GeoGebra. So the Spanish-speaking community seem to be much more enthusiastic. Maybe that's just the way they are, but it's very interesting. And the Americans have come in through, again, a different bit of software, and then they've come in and now using GeoGebra. Back in sort of 2005, 2007, there were lots of sort of open source freeware things quite similar to GeoGebra, but for one reason or another, we're still here and most of them aren't, which is kind of interesting.
Yeah, I mean, I actually feel like the community is a big reason behind that, and also just the fully open source approach of that. I mean, my experience interacting with Marcus, he's very collaborative and inviting, and he's open.
He's a special person, isn't he? He's part of the, obviously a very big part of the reason for his success, because he's had the idea and he's driven it forward. Yeah, it's just interesting how we've made, over the years we've made certain decisions which have been very beneficial. One of the things I've realised is actually working out what not to do is also very important. Because if you try and do too many things, you've really got to focus on what you do. Again, one thing we do, I mean, we have releases every single week, so we're really pushing stuff out. We don't. Some companies wait 6 months, they do a release, and then they wait 6 months, do a release. I can't see that working for us. The fact as you say, we get the community feedback straight away. We can fix bugs quickly. We can, really get feedback, and the community see that and they really like that.
What are some examples of some things you decided not to do that were important that you didn't do from your perspective?
So at one point we had a Python plugin which we killed. So part of the reason for killing that was, so in 2009 we started playing with HTML5 using the Google Web Toolkit compiler, and doing the Python it wasn't possible back then. And even if we'd had it in now, it would have been a really big download. So we had it in beta, we never released it, which with hindsight is a good decision. So we never had to support it.
And I know when I was looking at things in the past, most of your code base was in Java, but then now you were using Google Web Toolkit to generate JavaScript. Is that still kind of your approach?
Yeah. So I mean, the fact that we had to find a way to split the code into the. So we had to keep the old version running and be able to add new features and bug fixes, but also split the code into the two versions. So the one to version online and the old one. So it's a big refactoring project. So we split it up. So we had to split the one code base into 2 bits, which we call the common bit and the desktop bit. And then we had a third, and then we had to add on the web bit to make it then run with the Google Web Toolkit, so you could do the graphics and so on. So all the math logic is sort of all the same code, and then the GUI logic is different in both bits. And the really unexpected bonus of doing that was that along came Android, and its native language is Java. So actually, it was reasonably straightforward to then get a native Android app. And we're actually using the same development model that Google use. So Google writes stuff in Java and do exactly this. So Google also has a tool called J2ObjC, which converts Java to Objective-C. So again, with a bit of work, we now have a native iOS app. So the splitting of the code was very painful, but it's put us in a really powerful position now that we can deploy exactly the same code and bug fixes and bugs to 4 platforms. And again, there's other unexpected benefits. So on Android, you get really good stack traces on crashes. So we get a bug, we identify the bug quite quickly on an Android crash. It's got millions of users there, and then that bug fix then goes across. So it helps the stability of everything, which makes sense with hindsight, but we didn't plan it.
So zooming out a bit, big picture, you've got Marcus is in Lindt, Austria, and you guys have, I'm trying to remember what you called, but you have basically a network of educators.
Treasury institutes, we set those up, yeah. So that's worked really well.
And then you have a network of developers. Well, I'm not sure how big the team is, but I know it is at least when I was interacting with you, it had the feel of a true community open source project. It wasn't one entity running the whole thing. Is that still kind of what?
Yeah, I mean, I think a lot of people think open source means anarchy, but it definitely doesn't. Marcus and I are in charge of the code. We're very strict about what we allow in and so on. So because of it's now much more difficult because of all this platformy stuff and to actually get started as an open source developer. But there's a chap from China called Chris who's actually submitted a few patches recently, so it's still possible. The developer aspect, so yeah, I mean, our developers are all paid now, really. Yeah, back in 2009, we had George Stir, who was a volunteer developer. He's a teacher from California. So he did a lot of the spreadsheet stuff and the statistics calculator and so on. So back in the day, we had a lot of volunteer involvement, but less so now.
Okay, great. Maybe now we can zoom in and have you show us some functionality of GeoGebra, the different pieces of it, and then maybe we can, after that, we could zoom back out.
Yeah, sure. So what I've done here is I've just shown, this is just to show a little bit about the design of GeoGebra. When I show it to you, you'll think it's obvious, but no one else has, even though it's open source and the idea's out there, nobody's actually copied it and done this well. Here's a geometric object, a circle, and I can put a tangent on that. So it's a sort of geometric object, tangent kind of geometric construction. But I can also let's do a definitely non-geometric object. So a sine wave. Pop point on that. And find the tangents tool. Again, the tangent command or the tangent tool, they work exactly the same on the geometric and the non-geometric objects. So actually, it actually breaks down the barrier between geometry and algebra. You can treat the circle as, if we look over here, actually, we can treat the circle as a geometric or an algebraic object. So you can see there's the equation moving. So is it a geometric or an algebraic object? And actually, that's the wrong question, really. There's just an artificial barrier, which you kind of realize shouldn't be there. And this helps break that down.
I mean, besides the fact that that's just really cool. So when you enter the circle command up there, like the circle function, it looks like that creates procedurally that creates the circle equation with the 2 offsets. Is there any ability to infer that procedural nature of an equation by being able to interact with it, or is there any way to like hook into that so that when you create an algebraic equation with a geometric interpretation, that you can interact with it and have it dynamically adjust like this, or is that just like specific to certain things like the circle function?
I think it just depends how you create the object. I mean, it's so I can move these points on top of this circle and we'd get a circle, but it would just behave in a different way. Does that make sense? So it's just everything's built on dependencies. So there's a few different ways to draw a circle. So we've got you can do a circle by center and radius, or by center and a little length, or we can do circle through 3 points. Does that make sense?
Yeah, yeah. I guess my question was if that geometry, or rather the algebraic expression responding to interacting with the geometry was something that was like hard-coded specific to that one example, or if that's just a more general thing that you can...
Yeah, it's more general. So when you make a circle, you don't make an algebraic circle or geometric. You make a circle. So the graphical view is one view of the objects, and then the equations is just a different view of the objects. We have a way to draw every object, and we have a way to show the equation of pretty much every object. Obviously not true maybe for a polygon or something, but so we draw a polygon. Then what we've decided to do is over in here, then so T1's the polygon, and it's the number there, 32, is its area. So the algebraic view of the polygon is 32 rather than an equation. So here's this example might appeal to the people who aren't interested in what I've said so far. So here's an assessment object in Geogebra. So a lot of people are doing this at the moment. This is a really simple minimal example. So it's randomized. So that 9 can just be a 1, 2, 3, 4, 5, 6, 7, 8, or 9, just for the purposes of an example. So let's pop in the right answer. Let's just take a chance to show off the equation editor a little bit, which is quite nice. So let's just. We've got a super nice equation editor built in, super nice formula rendering built in. You know, Geogebra's got lots of different components that all work well together, which is one of the reasons for its success. Let's put the correct answer in, which is sadly a bit boring with no square roots. So straight away, the stuff down here is like the API, so the grey buttons and the correctors. So it's gone correct as true. It said correct as false just now, as you probably all noticed. And we can just mark it right or wrong. We can show the correct answer, and perhaps more interestingly, show the full worked solution for something. So that's a really powerful idea, because firstly, you can give every student a different question with the randomization. Secondly, if a student gets a question wrong, you can then give them some feedback and say, here's how you should have done it. And then again, using the randomization, you give them a slightly different question to try. So the checking is all done inside Geogebra. Everything in this rectangle is part of the Geogebra object, all the updates and the dependencies and so on. Obviously, a lot of it's hidden away, so the student can't see it. And because it's all in the Geogebra blob, the interface to whatever LMS, whatever you put it in, is very simple. You can simply send a Boolean variable, correct, not correct, show solution, hide solution. So the interface between Geogebra and third party is very, very simple. That's really important for doing fast integrations and helping work out where the bugs are and so on.
So I guess, I mean, this maybe is obvious, but there's a computer algebra system underneath this.
That's an interesting question. So your short answer, yes, we've got a full computer algebra system. But actually, when you're assessing these things, it's actually mathematically undecidable whether the two expressions are equal. So a computer algebra system isn't necessarily the right approach. So actually doing a numerical checking is actually more robust, if that makes sense. And you don't have to load the big computer algebra thing as well. So it's a win-win. But sometimes you do need to go to the computer algebra, but if you can do it without, that's better often.
I have a question about checking that numerically. Can you handle steps or holes or other discontinuities in functions?
Not with numerical checking. But again, the computer algebra would say that x over x is equal to 1. So the computer algebra doesn't help with holes and discontinuities either. So, and on the whole, if the student's clever enough to find an example that's the same mostly, then they're probably okay to, if they're trying to hack the question, then you should give them a correct answer anyway.
Yeah, it's interesting, because my there's kind of these two different, well, I mean, there's different philosophies of teaching math, right? Like, are we teaching people to follow procedures? Are we teaching, trying to get at some deeper level of understanding? And can that be, and both are important, right? But it seems like being able to play with it and interact with it and see, but at the same time being able to get feedback, or be able to see some representation of the changes you're making is an important to being able to develop deeper levels of understanding.
Again, here's perhaps a more exciting one, because I mean, anyone could do a type in the answer box question. That's not that exciting. So this one, I've got the answers are, what I've done is made some target objects as hidden GeoGebra objects. So there we've got target 1 and target 2 reached, and that's the API again telling whichever system that the students made some progress on this. Target 3 reached, job done. So again, that's done. The check in there is again done numerically, because doing it with computer algebra is very hard, and again, it's not as robust, because if the student does a different method, then the numerical check will tell them that you've done it. So just perturb some points and make sure things are moving correctly, moving sort of as you expect. Whereas if you're too strict, you could mark the student wrong when they've done a more inventive method. So kind of interesting.
That's really cool. So you can basically assign a geometric activity and allow for creativity in the solution. That's awesome.
Yeah, I mean, the nice thing about GeoGebra as an assessment tool is that you can do the type and the answer stuff, but you can also assess by the students dragging points or dragging anything or moving things or using tools. So, however, we're not limited by traditional assessment. You can actually try and assess skills that aren't previously accessible. A pen and paper, a traditional pen and paper exam, you can only assess certain things, can't you? Whereas now you're only limited now by your imagination.
Yeah, that's always been something that I feel has been lacking in. I mean, clearly it's been there because I haven't seen too much of the assessment side of GeoGebra before. But in past experiences with online math software, the thing that has always really irked me is the lack of potential for creativity in your solution, which is, I think, really where students can fall in love with math. And if they're forced to do it in a way where, like, even if they get the right answer and it's wrong, they're going to start hating it. So it's awesome.
At some point, I'd like you to talk a little bit more about your institutes and about GeoGebra Tube.
Oh, well, this is it's not called GeoGebra Tube anymore. It's the old name, so it's just GeoGebra. There's sort of two things that go together here. So one thing we've been working on is GeoGebra Classroom, which I'll show you in a minute. Then we also thought, we've made this GeoGebra Classroom thing, we now need some curriculum for it. And I don't know if you've heard of illustrative math. So we've made some open access, I think it's Creative Commons stuff. So we've adapted a lot of that, and we've sort of, it's made for in-person classrooms. So we've adapted that for the online learning a bit more. So we've put in the bits that were missing. Let's just dive in and find something random. You can see we've filled in we've done most of it, and we've got a little bit more just to fill in for the whole course. Let's pick a random lesson. It's very dangerous. So you can see we've got some sort of student activities. So, and that was all possible before, but what we've launched this year is the GeoGebra Classroom. So I'm going to click on the Create Class here. And let me share that link with you in Hangouts chat, if I can find it. Here we go. So if you'd all like to click on that link, let's see what happens. So this is so on my screen, obviously, I've got the teacher view, and you've obviously all got the student views. So perhaps if you'd like to have a go at some of the tasks, just quickly. So the key idea really is that I can see live what you students are doing. And it's really simple. So you didn't have to log in to access that. which is really important for sort of privacy and so on. Teachers really like that. So as Joel said, for a long time we've had the material sharing platform, used to be called Geogebra Tube. So now I think there's over 1 million publicly shared resources made by teachers. That's been really successful. The people have done that. We've now added this extra bit on, so teachers can now really leverage that in their classes, especially with the remote learning that we're inflicted with at the moment. So on this screen, I can see live what you lot are doing. Could hide your names so we don't embarrass anyone. There we go. Down the left, you can see it's not ideal yet. It just says task 1, task 2, task 3. So we'll fix that up to make that look prettier. And that's just been launched as well. So we've got lots more things on the roadmap for making this super exciting.
For the free response questions, is there a way to enter LaTeX or something to do math operators, or do you just use your keyboard input?
We've got we have the editor of the full thing with an API, so we're going to be adding that soon. Yeah. What I can also do, I can click on a student. So let's pause everyone and make you listen to me. So I can actually click on a student's thing, and then I can interact with the applet. So what I can do this, but this won't go back to the student yet. I can interact with it and maybe say you should have done that. Maybe get rid of those. Try this. I can see what they're doing. I can interact with it. I can give them feedback. Some live interaction coming soon as well. So, is
there? I guess if someone wanted to use a stylus for this, I guess it would just work because it would technically be mouse input, right?
Yeah, I don't know. A stylus might be mouse or touch. I'm not sure. Yeah. Just reminds me, I haven't done any of this. We've also got full whiteboard software, which again is the same engine. So this is the Bavarian Ministry have contracted us to make this. So they've got their own version, which they're very privacy focused, which is one of the reasons for having a sort of custom solution. So when their students are using it, all the data saved to their own servers. We've got our version on Geogebra.org as well for everyone else to use.
What organization were you talking about? I didn't catch that when you.
In Bavaria, in Germany. So we can plonk in a Geogebra object here. So there we've got the full Geogebra stuff there, but then we can stick an equation over here. Or we can use the pen tool, do some writing, or all the usual sort of whiteboard sort of stuff that you'd expect. So again, that's quite a powerful sort of student scratch pad idea that some publishers are looking at now.
Can you mark up the graph created by that Geogebra object? Oh, awesome! Yeah, that's great. I have to imagine this is a really great tool for smart projectors.
Yeah, I mean it's sort of been designed for the teacher to use at the front of the class, but obviously iPads as well are quite an interesting use case.
Can you share any information about your partners with publishers or people that have integrated with you?
Yeah, that's easy. Everyone uses us. So pick a big publisher's name and we're on their platform somewhere. Again, we've got 3D, so all the things you can do. You saw with the 2D stuff, we've got 3D tools for all the things you would expect as well. And again, it all works exactly the same way.
Do you have any resources? I mean, I'm sure you could create them using both the 2D and 3D tools, but are there any native resources for visualizing complex functions like Riemann mapping, conformal mapping, or perhaps just native complex number support as a type?
Yes, to some of that. This one. Yeah, so the spreadsheet again. So I'll answer that and the spreadsheet at the same time. So the spreadsheet's just another view. Like we had the graphics view is the geometric view. The algebra view shows the equations. The spreadsheet view just happens to show the objects that have a name like B3. So a normal spreadsheet can only have numbers in it. In Geogebra, you can have any geometric or algebraic object in. Yeah, so I've got a complex number in cell A1, and I've squared it.
Okay. Huh, that's cool. And is there support for that in like any sort of graphing ability? Like, could you say graph the complex plane, or maybe like graph the real part of it's like throwing some complex numbers into a like say a sine or cosine?
We have just added some support for complex functions, so I can do. I think this is going to work. Yeah, so that's working okay. Let's put the font size up a little bit. So I can define complex functions, and there is some support for plotting them, but I can't quite remember how to do that. So there's a little bit of support for that, perhaps not everything you want. Oh, there we go. Maybe that answers your question. I have to click on the marble.
There we go.
I don't know what that's plotting, but it looks cool.
It looks like it's trying to do like a parametric thing, but that doesn't look like x plus sine. Oh, it's because it's putting 3 plus I into sine of
No,
x.
it's not to do with the what's plotting. It's plotting f, not z1. So forget the 3 plus I. That's not to do with it.
Oh, that's just a point, right? Yeah, interesting.
So with your institutes, what's the flavor of the institutes? I guess the flavors perhaps changed with COVID, but
it's a difficult question because it's not. They're all different, really. I mean, and some are more active, some are less active. Some focus on teacher training, some focus on more research things. You know, there's no general answer for what they do. The ones in Spain are particularly well organised. So I think there's 5 in Spain in different regions, and they work really well together, and they organise conferences. I think there's quite a lot of activity in South America as well. Yeah, it's just it's different in different parts of the world. They do different things.
and are the institutes organized centrally, or does each group just more of like an affiliate, and they say we want to do this and they run it?
Yeah, exactly. They're fairly autonomous. They're often based at university.
And what areas are most active? I guess you've talked about Spain. How about here in the U.S.? Are there different pockets of people here in the U.S., or is it most of what's going on through the publishers? Or
yeah, I don't know about different bits of the U.S. In terms of Mexico and China are really big at the moment, just in terms of on absolute figures. On relative figures, you're probably looking at countries like Norway and Denmark. They've kind of really got Geogebra built into their curriculum, so it's almost compulsory that they use it. Again, it's interesting how different bits of the world do different things. Very interesting. Mexico seems very big on Android phones. So I'm just guessing. It's a complete guess, but I'm just guessing that Android phones are just much more common there, whereas other countries are more likely to have iPhones or desktop. So Norway, they typically have proper Windows laptops in the classroom.
I'm diving into the tech. I'm kind of curious. I'm assuming that you can serialize all this stuff pretty much, and are you representing it as JSON, I guess, or
XML? That was, I guess, Marcus decided that back in 2002 or something.
And when you use the tool, this may not be obvious to people, but typically, at least what I remember was using a Java desktop application and then generating kind of pages. Is that still what you do, or is that still common, or is it this advanced to the point where you pretty much just use web versions?
So the Java tool's got the advantage that you can spawn windows off. So if you've got multiple monitors, you can have different views on different windows. Actually, it's interesting because as Chrome's added different features, we've been able to make it more and more like the desktop version. So you can now do native copying images to the clipboard from Chrome. So that's probably the last missing step that was in the desktop version but wasn't in the online version. So they're pretty much functionally equivalent now. But again, the Geogebra notes, that's online only. So we're sort of leveraging iframes and other things to put different components in. But yeah, it's interesting that people keep worrying that we're going to kill off the old desktop version, but I think particularly we keep having to promise Finland that we won't, because they're very reliant on it for exams and things. So the sort of killing off things is difficult. Yeah, definitely time for some questions though.
Okay.
So I have a question. I noticed it looks a lot like Google. So is that like your inspiration for this tool, like a Google type look?
Yeah, I think we use material design, and yeah, often if we're not sure about a decision, we'd say, yeah, let's copy Google, because they tend to be very data driven. So we kind of assume they've done the hard work for us.
Well, thank you again, Michael. I've really enjoyed your presentation. I'm glad everyone's been able to see more and learn more about what you're doing. We look forward to collaborating. So thank you. Is there trying to think, I was going to say, is there anything we can do or answer for you? But yeah, so certainly if there is that, but I haven't primed you with that. But looking forward to digging in and seeing about integrations. We have in our item bank enabled our Learnosity item bank, the the question types that you guys have done, and then I know we've also talked about just having a native GeoGebra LTI, which I guess that would be a question. Have you guys done, or do you have a GeoGebra LTI already that does deep linking, or are you planning on that?
Yeah, we've done that for a big publisher quite recently. So we've got sort of a modern working thing. We can probably get up going quite quickly.
Oh, okay. So you have you've built the LTI support in for launching worksheets, or
yeah, we can launch an assessment item and then send back whether it's correct or not. It basically look like that's working in.
Okay, thank you for your time. Anyone else have any last comments or questions?
I just want to say thank you. This has been really cool. I've used GeoGebra a little bit before, past classes, and I really appreciate what you guys do. And thank you for the presentation.
Great, thank you.
Okay.
Okay, bye everyone.